Welcome to this presentation about LabPcap. My name is Sébastien Michaud. I'm a French engineer. I'm CLA and CTA. I work in Framatome, which is a nuclear civil nuclear company, and I'm a member of a private community to my company. Dedicated to test and measurement. And I'm also a member of the LabVIEW, which is the leading French-speaking LabVIEW user group. It's the leading French-speaking user group in the sense that it's the most famous and the most active French-speaking LabVIEW community. So we have a lot of stuff. We have a YouTube channel, we have a LinkedIn page, a website, and each event can be attended online or in person. So if you speak French, feel free to join us. About the content, I don't have many slides, but I have a lot of examples to show because I think it will be more fun for you guys to see some code and some demo. So here we go about Wireshark and the OSI model. So Wireshark is the most famous network packet analyzer. It has been around since 1998. And Wireshark capture packets at the layer number 2 of the OSI model. And that's actually where my toolkit, my library LabPcap stands. LabPcap allows to capture packets at the layer 2 of the OSI model, just like Wireshark does, but within LabVIEW. SharpPcap and LabPcap. So basically, LabPcap is a wrapper of SharpPcap. And that's what you can see here. We have three layers. The first one is LibPcap and pcap, which is written in C and C++. And after that, we have SharpPcap, written in C#. And on top of that, we have LabPcap. So the question is, why SharpPcap? Actually, we looked for several solutions before standing with SharpPcap. At some point of our investigation, we talked with the main developer of NPCap. His name is Fyodor. Maybe some of you know this guy. It seems he's quite famous in the cyber security area. His real name is Gordon Lyon, and actually it suggested us to have a look at SharpPcap, and it was actually a good suggestion for the reasons I have listed here. First of all, SharpPcap is open source. It's free. It has an easy API, and because it's C# and because it's deployed as a .NET assembly, it's really easy to interface it with LabVIEW. Unlike LibPcap, which is really hard to interface directly with LabVIEW. SharpPcap covers all LibPcap features. It is cross-platform. It works on Linux, Windows, and macOS. But the .NET interface of LabVIEW, for now, only works on Windows. But on the LabVIEW roadmap, you can see that it will soon be working on Linux. SharpPcap is compatible 32 and 64 bits. With it, you can inject and sniff network packets with a high throughput. You can use pcap files. You can dump packet to pcap files. And you can run it with an offline mode, which means you can read pcap files. And you can use advanced filtering, advanced packet filtering, using something called BPF for Berkeley packet filters. And I'd like to thank Chris Morgan and Ayub Kanish, who are the main developer of SharpPcap, for their kind help and good support. So about LabVIEW, basically, each class of SharpPcap is wrapped in a LabVIEW class. Same thing for each interface of SharpPcap, and same thing for the inheritance of SharpPcap. So everything is mimicked in LabVIEW. So here we go for the demo. I have 13 examples here. So here we go for the first one. So the first one is called get next packet. Let's take a look at the code. So as you can see, everything is written with LabVIEW object-oriented programming. And the first class here is called device configuration. If I click here, you can see a lot of properties, and all those properties come from LabPcap and pcap. So if you need help about those properties, you can take a look at the LabPcap and pcap help on the website. So that's the first thing to do, configuring the device. And as you can see, I've put here an option called promiscuous. The promiscuous mode is something really interesting and really important because it allows you to capture packets, all packets coming to your network interface card, even the packets which are not targeted to your MAC address. So device configuration. After that, you have something called the live device list. It's a class which allows you to detect all hardware available, all network hardware available on your computer. After that, you can select a device, a live device, the green wire here, LabPcap live device. And you can open the device, get the next packet, the very next packet, extract the data of the packet, close the device, destroy the references. So let's try this out. So we have this pop-up. So this window is not part of LabPcap, but it is part of the examples. So as you can see, we have several columns here. The first one is the connection name. It's a friendly name. So basically here we will use only two of them. The Ethernet connection, which is my current internet connection, and the loopback traffic capture adapter. The loopback traffic capture adapter is a virtual network device available on all computers. So the next column is the description of the device. I did a column about the current MAC address, and the last one is an ID. So it's not a friendly name, but it's the unique ID of the device. So for the example, I will just select the Ethernet device, and the code will wait for the very next packet. Let's try it. Okay. That was really fast because of the streaming with Ring Central. Okay, here we go for the second example. The second example is called capture N packets. So with this example, you can specify a number of packets, and this method here will wait until the specified number of packets is reached. And we have other new functionality here. The first one is the set filter here. So that's the kind of filter I was describing in the slide before. It's a Berkeley packet filter. A Berkeley packet filter is a very efficient filter. It's a way to filter packets at the kernel level of your computer. And yeah, that's it. And after that, we have a new class here. This one, yes, sorry. Yes, this one is called a capture queue. A capture queue is a way to get multiple network packets at once. So basically, you create the capture queue, and each device has to register to the capture queue here. And when you have some packets available, you can flush the queue, just like a FIFO in LabVIEW, extract the data, stop the capture, unregister the device, and dispose all the references at the end. So let's try this one. As an example, I can try to specify a filter here. I can try to specify a TCP filter, and we can wait, let's say five network packets. I select my Ethernet connection, and here we go. It was still very fast because of the streaming. And we have 5 packets. Yeah, it works. We can take a look maybe at some code. So this one, as you can see, you have a class called raw capture, and you have some properties here. You have the data in the form of an array of bytes. You have the link layer type, the packet length, and you have the timestamp. The timestamp is also a LabVIEW object reference. And you have the date in the form of a LabVIEW timestamp, but you can also get the microsecond and seconds. So let's try the next example. The next example is an infinite capture. That's why we have a while loop in the middle. And we also have something here called statistics. So it's a way to to see the number of packets received on your network interface card and to see if you have eventually dropped packets. Let's try it. Select Ethernet. Okay. So as you can see, all packets arriving on my internet connection are displayed here. The timestamp, you got the timestamp for each packet and you got the array of bytes for each packet. And you have the received packet counters increasing. Okay, next one. So the next one is the same as before, but I have specified two devices here. That means we will see the network packets of two devices into the capture queue, but we have two separated statistics. So I select Ethernet for the first one and the loopback traffic for the second one. So we are flushing the capture queue and we have received packets on the device one. Let's try to increase the counter of the device 2. I will just launch a command. I will just do a ping on, let's say, on localhost. And a ping command on localhost is managed by the loopback adapter. So when I will press the enter key, we should see the received packet counter increasing on the device 2. Let's try it. Enter. Sorry, I have a keyboard issue here. As you can see, it works. Each time I do some ping, I can see the received packet counter increasing on the device 2. Okay, next one. So the next one is an infinite capture, but you have the blue VIs here, and the blue VIs here are dedicating to dumping the packets to a standardized file called a pcap file. A pcap file, it is a standardized way to store network packets. You have the right method here. Actually, it used a method of LabPcap dedicated to dumping packets to pcap files. So it's a very efficient method, and that's why you can use it in a while loop. So let's try it with an ICMP filter. I close some windows, yes. And we will run it on the adapter for loopback traffic capture. Okay, I have to select a pcap file to overwrite. So let's take this one, overwrite it, yes. And here we go for a ping. And as it is an ICMP filter, I have to type in not localhost, but this IP address. Okay, I got some packets here. I have 8 packets because you have 2 packets per ping command. You have the request and the reply. Okay, so let's try to open this freshly written file with Wireshark. So I double click on the file and you can see I have my 4 ping command into my pcap file and everything show up correctly in Wireshark. Okay, next one. Okay, before the next one, I will show you the LabVIEW hierarchy of this project. So, as you can see, you have 3 children here. You have the green one, LabPcap live device, which is dedicated to real packet capture with real hardware. But you have also the purple one, capture file reader device, which is dedicated to read pcap files. And you have the blue one, we saw it before, dedicated to dump packet to pcap files. So the next example is dedicated to read packet from pcap files. That's why you can see the purple color of the reader class. Regarding the method, it's the same method as the live device class. So let's try it. Let's open our previously generated pcap file. And we got our 8 ICMP packets. So that means you can analyze some traffic offline. Okay, the next example is a mix of the 2 classes. It's a mix of the live device class, the green wire here, and the purple one. So basically, here, with the first iteration of the loop, we will capture packets, real packets, dump those packets to a pcap file, and with the second iteration of the loop, we will read the previously generated pcap file during the first iteration and display the packets. And as you can see, it's the same set of VIs, and it works thanks to inheritance. So basically, thanks to this inheritance, you can build a replay mode. So let's try it. Let's write into this file. Yes. and take this one. Okay. So the first part of this array is the capture, captured packets, and the second part come from the pcap file. And as you can see, we have the same data for the first and the second iteration of the loop, thanks to the inheritance. Okay, the first set of example was dedicated to capture packets, but the next set of example is dedicated to sending packets, because in LabPcap you can send packets even if you can't do it in Wireshark. It is possible with LabPcap. So let's try the first one, and let's open Wireshark again. On the loopback, where is the loopback? Yeah, here. Okay. So let's take a look at the code. Here I will automatically select the loopback adapter, open a connection to it, apply an ICMP filter, then I do a ping command. I get the next ICMP packet, which will be very likely the ping command. I extract the data, and then I resend the exact same data with the send packet method here. So let's add an ICMP filter to Wireshark. Okay. And let's run this little guy here. We should see, in Wireshark, we should see the ping request here and the answer of this request. And we should see the exact same request after that and the answer. So we should see 4 ICMP packets. Okay, that's the pink, the line in pink here. So the first one is the command. Here you have the response, the reply, and the next request here come from the send packet method here. Okay. Next one. We just sent one packet, but actually you can send multiple packets at once. You have a functionality in LabPcap called send queue. A send queue is a buffer of packets, and you can send this buffer at once, and you can send this buffer as fast as possible, or you can send this buffer in a timed way. You can specify the timing between each packet. So for this example, I have a UDP filter, and here I generate a UDP broadcast packet. I get this packet and I send it again 20,000 times. So if I run a capture of Wireshark on the Ethernet with a filter on UDP, no, let's take this filter. Because of the streaming, we have a lot of UDP packets. So let me add this filter. Yes. And let's run it on the Ethernet. And we should see, yes, as you can see, we have 20,000 packets, 20,000 UDP packets. I can run it again. And it should increase to something like 40,000. Yeah. Okay, you can mix sending and capturing. So instead of using Wireshark to show you the packets, I can use LabVIEW. So that's why here you have the upper part of the code dedicated to sending the packets. So each time I will click on transmit, I will send 10,000 packets. And the lower part of the code is dedicated to the capture. You have two loops for timing reasons, but the first loop is for the packets and the second one for the statistics. So let's try it. UDP, yes. Ethernet. Okay. So you can see all the packets arriving here. We have a lot of packets because of the streaming. And if I click on transmit here, we should see the counter increasing to 10,000 more packets. Yes, we got it. Okay. So the next example, it's the exact same thing, but instead of sending packets as fast as possible, I have set this boolean to true, and I have used here the iteration terminal of the loop. So as you can see, it's wired to the sequence entry, sequence input, which means I will send packet. I will send one packet each second. And it's an example on the loopback traffic adapter. So I will start Wireshark again. Loopback, ICMP. So we should see in Wireshark, we should see the first ping command, and then we should see 6 ping requests separated by 1 second. So let's try it. 1, 2, 3, 4, 5, 6. I don't know if it was obvious on your side, but you can trust me, it works. Oh yes, we can check the arrival time here. So if I take this one and this one, each one is separated by 1 second. Yes. Okay. The next example, it's the exact same thing, but instead of sending 1 packet each second, you can specify the timestamp. So here for this example, I have specified variable difference between each packet. So 1 second, 3 seconds, 1 second, 3 seconds, 1 second. Let's try it. Oh, sorry. I will run it again. It will be more clear. Yes. So 1 second, 3 seconds, 1 second, 3 seconds, 1 second. Yes, it works. And the last example, use a pcap file. So basically, you can fill up a send queue with the content of a pcap file. So that's the first part of the code here. We read a pcap file and add the packets to the send queue. And when the send queue is ready, we can transmit this queue to a real network device. So I will not run this example. I think I've done enough demo. And yeah, I will just go back to the slides. The slides. Yes. Okay. So use cases for LabPcap. So first of all, do not use LabPcap if you can use primitives, TCP, UDP, drivers like Modbus TCP, and so on. LabPcap is not a library to use first to build a driver. LabPcap is more about corner case. With it, you can build a network spy within your LabVIEW application. You can build a network analyzer within your LabVIEW application. You can actually build a full driver with LabPcap as the hardware driver, and with you adding some specific dissector and constructor. That was actually our initial case at Framatome. With LabPcap, you can use pcap files. So that means you can use previously recorded traffic to capture packets offline or to inject packets. And you can also, as I said before, you can also dump network to pcap files. With LabPcap, you can perform some statistics on your network. If you have written a protocol, no matter the protocol, let's say as an example, MQTT, you could use LabPcap to build some unit tests on MQTT. You can use LabPcap to inject faults into a network. You can use it to overcharge a network or to test its robustness. And if you are talented enough, I'm not, you can use it to simulate some cybersecurity scenarios. Okay, what's next? So the library is quite advanced in the development, but I need to add some VI documentation and to run Antidoc to have a proper PDF or proper documentation of the project. I have to run the desktop execution trace toolkit to check if I have some memory leaks. A next feature will be to wrap up the packet.NET assembly to easily parse and construct packets, and maybe later VI palettes and a VIPM package. Okay, so the most interesting thing, I think, is that this project will very soon be open source. So I see a question in the chat. What is the licensing situation of LabPcap? Actually, it will be entirely free in July, I think. It will be available on the Framatome ATMS community GitLab. And we currently have a bunch of reviewers and testers. You can see the names here, and I'd like to thank all of them. But the thing is, at some point of the development, I had to write only one C# file. It's the capture queue. But I'm not a C# developer. So it will be really cool to have a C# developer reviewing this file, maybe maybe improve it or fixed maybe some issue I had introduced. I don't know. So yes, if you are interested by this project, feel free to join me, and yes, we will be happy to have you on board. So that's it. If you have any question, I can try to answer. My English is not really good. I'm not fluent, so please speak slowly or write it very clearly in the chat. No question? Thank you, Gerd. Thanks. Thanks to all of you. Have a nice summit. And thanks to the organizers. A special thanks to Christian Butcher for his kind help. Oh, I see a question. Does it support pcap ng format? Yes, that's a really good question. Actually, it does. pcap ng stands for pcap next generation, and LabPcap support pcap ng format. But as far as I know, the LabPcap support it, but not fully. It's not fully supported, but you can, instead of specify the pcap file extension inside LabPcap, you just have to specify a pcap ng extension, and it works. But the issue is more on the LabPcap side. Will it work on a compact trio? Yes, good question. So for now, the .NET interface of LabVIEW doesn't work on Linux. But if you take a look at the LabVIEW roadmap, it should work on Linux on 2026. So it should work on Linux, but I don't know if it will work on LabVIEW real time. I don't know. Maybe someone in the audience can answer that question. So my guess is, if you, in the future, if I'm correct, you will be able to use LabPcap on Linux, but I'm really not sure about a compact trio. If you want, I can try to show you the LabVIEW roadmap. That works? Okay. So it should work. So let's take a look. LabVIEW. Okay, it's in French, but yes. .NET Core under Linux. Oh no. Yes. 2026 plus. I don't know what the plus means, but you're welcome. Yeah, maybe. Or maybe 2030. We don't know. Actually, in my company, we work only on Windows for now. We have some German colleagues who work on Linux, but the vast majority of test benches are done on Windows. Maybe you can spend some time looking at the code if you want. Let's try to see. Yes, we can try to take a look at this. The pop-up. So here you have the pop-up, and you have some very easy to understand code. So basically you have a count here, which is a number of network devices on your computer. And after that you have some properties, and you can choose which properties suit you and just display it. And that's it. That's the way I feel the multi-column list box here. And what else? We can take a look at the thank you, maybe. Yes. So as you can see, each method, sorry, each method of LabPcap has the same name as the method in pcap. Let's take this one. Oh yes, there is a casting here, but there is a good reason for the cast. If you are interested by it, I could explain it, but it could take a long time to explain. But it's about distribution in PPL. What else? Oh yeah, properties. Properties. Let's take this one. Actually, I didn't know that it was possible to to build some properties, object properties, without a corresponding internal data into the class. I didn't know that. Actually, you can build any properties, uh, but having quite nothing in the internal data. I just have a reference here, but I still have a lot of properties. Yeah. Another interesting thing is this file. I don't know if some of you guys know this kind of file, but it's quite interesting, I think. This file allows you to load a specified version of an assembly, of a .NET assembly. And if you don't use it with LabPcap, you will have an error because assemblies has been built with a special set of dependencies and a special version of dependencies. And if you don't add this .config file, you will have an error. This one is labpcap.lvproj.config, but you can also add it with exe, like LabVIEW.exe, LabVIEW.exe.config, or myexecutable.exe.config. Yeah. So if I build a VIPM package, it will be a challenge to manage this .config file. I don't know. I guess if you master Visual Studio Code, you should be able to grab or generate automatically this file, I guess. But basically, I just read some documentation about it and write it by myself. But it works really fine. But let's say I built a VIPM package in the future. Yeah, I will have a challenge about this file because I guess I will have to add a labview.exe.config file or check if this file already exists and so on. So yeah, if you have some ideas about it, I will be glad to hear it. Yes, good question. Actually, if you okay, we only have 2 minutes, but what I do, Andre, to answer to your question, I go to nugget.org, and on nugget.org you can see all the dependencies of an assembly, and you can see uh, the version of the dependencies. And if you are brave enough, you can use newer version of dependencies. But if you do it, you will have to use a .config file. So I can show you maybe. Here you have #pcap. You have the dependencies. Oh yeah, unsafe. You have the dependencies here, and let's take system.memory, and system.memory as the famous compiler services.unsafe here. And the current version is 6.1.2. So that's how I did it. I just looked at the dependencies graph here. Okay, it's 9 o'clock, so I think I will stop sharing. But feel free to join me on LinkedIn and so on. Have a nice summit. See you.